The next tuning module is wax model tuning. If you remember, and if you watched the previous videos, we have explained that the wax model is a combination of CPA model and Cutinho model. Cutinho is responsible to calculate the fluid phase properties of the wax phase, and the CPA model is responsible for calculating the phase properties of vapor or liquid hydrocarbon or aqueous phase. So in order to tune the wax model, you need to tune two models actually. You need to first tune the CPA model and the Cutinho model. The Cutinho model can be tuned using WDT data, and the CPA model can be tuned with any saturation properties, PBT lab testing data. Okay, so in order to tune a model, as we explained before, you need to first characterize the fluid using the wax content data. Why we need to do that? Because we need to tell the Cutinho model how much of this fluid is actually normal alkanes. Because in the wax modeling, it is assumed that only normal alkanes participate in forming wax phase. So we need to tell Cutinho model which part of the fluid is actually waxy components. By doing wax characterization, we are separating the normal alkanes compounds using the wax content data, which has been measured experimentally, and then characterize it so that the Cutinho model can recognize the normal alkane SO2 components. When you do a wax characterization, you can feed it directly to the wax tuning model. The model will change the Cutinho parameters so that it produces the experimental WDT data. Or you can first characterize the wax component, the wax fluid, and then feed it to the CPA model tuning, use saturation properties, PBT lab testing data, anything, tune the CPA model, and when the CPA parameter was tuned for that fluid, you can feed it to the wax tuning module, and then the Cutinho model is fixed. It doesn't work the other way around. So you cannot tune the wax characterization, you cannot characterize the fluid, feed it and tune it with WDT data, and then feed it to CPA model. That's not gonna work. You need to first characterize it, then tune the CPA model, and then tune it with WDT data. And you can always tune the WDT data straight from the characterization. But you need to remember, when you do that, your CPA model is not tuned. So that the prediction may not represent the saturation behavior of the system. So in general, for wax tuning, you need to characterize the fluid with wax, and then you have two options: either directly tune the model using the wax WDT data, or you can first tune it with saturation properties or PBT lab testing properties, experimental data, and then tune it with WDT data. This is the recommended way to tune the model. And whenever you use straight a characterized fluid into the wax model, you receive a warning that this fluid has not been tuned with saturation properties. But it lets you to do the optimization, but it gives you a warning. And so the only thing I want to add at this point is this data. Why WDT? WDT stands for wax disappearance temperature or wax dissolution temperature. So what is the difference between WDT and WAT, which is more familiar in the industry? Why? Because if someone asks you, what is the freezing point of water? You probably say at atmospheric pressure will be 0 degrees. But you need to remember that 0 degrees at atmospheric pressure is not the freezing point of water, it's the melting point of ice. So the freezing point of water may be less than 0 degrees. The same thing stands for wax formation. The WAT data is like the freezing point, is the wax appearance temperature. It may be different from the thermodynamic equilibrium point. Again, like freezing point, which might be different from the equilibrium point of ice formation, the VAT can be different from the equilibrium point. But WDT is the equilibrium point of wax formation. So what we need to do here, what we need to tune the thermodynamic model is to use the thermodynamic point of wax formation. Then you can by having both WDT and WAT, you can predict what would be the WAT point by reducing the subcooling temperature from the wax phase boundary. I'm going to explain that in the next videos where I'm going to actually tune a model for wax, and then we will show you how you can do that. Okay, now I'm going to show you how you tune the wax model. As I explained earlier, in order to perform any wax calculation, you need to characterize the fluid, and in wax characterization, the fractions of normal alkanes are identified. And when they are identified, new pseudo components are made only out of normal alkanes, which will be denoted by N letter. So it will be either you will see a number of pseudo components like N6 to N10 or N20 to N25 or N63 plus. So when you see a pseudo components denoted by N, and then that is that fluid has been characterized with wax and can be used for wax modeling. Okay. So to tune the wax model, you navigate to this wax model tuning. Okay. And you just need to enter the WDT data. Again, for this Pedersen book, I don't have any WDT data, so I just enter a sensible value that I assume that this is the value. It's 52 degrees at atmospheric pressure. And then you just need to choose and activate the wax characterized fluid, and then press run. That is simple. That is the direct way. So if you remember from the presentation, you had two ways of tuning the model. First is to directly feed the characterized fluid into tuning. That will only tune the Cutinho model. And the other one is that first tune the characterized fluid with saturation properties, which tunes the CPA model, and then feed it to the wax tuning model to tune the Cutinho model. So by this way, both CPA model and Cutinho model, they are tuned. So let's try first the direct way. When I press tune button, it gives me a warning. Say the active composition has not been tuned with experimental data. Please use saturation tuning module to tune the model with saturation. Otherwise, the predicted wax phase boundary will not be representative of the actual fluid phase behavior of the system. Would you like to continue wax tuning? I don't. Okay, you can continue and it will tune the model. So, but let's close this for now. I go back to the CPA modeling, which you already know how to do it. Okay. So I activate the wax characterize fluid, and then I have the saturation data, but the problem is that it has not been connected with this fluid, so I need to enter it again. So just to show you, when I say this one, the selected experimental data and the active composition do not match because index was outside of the, it's the error of inside. So because these two fluids, they are not matched, I have saved this saturation experimental data with this fluid. I can load this, but I cannot load this with this fluid. It gives me an error. This is right. Okay. So I have saturation properties data for this, and I say at 97.5 degrees, the saturation pressure is 200 and the density of the saturated liquid is 0.6. And I name it SAT for wax calculation, and I save it to the database. Now this experimental data is connected to this fluid. Okay. So let's tune the model first, very fast. So the HydraFLASH now tune the CPA model parameters for this fluid, and now I can save this SAT tuned. So I'm happy with the suggested name, although I can change it, but I'm happy with the suggested name, and I just press this one to add this to the database. Now, when I first characterize the fluid with wax content data, now I tuned the CPA model. Now I need to tune the Cutinho model. Okay, so to tune the Cutinho model, I go to the wax model tuning. The activated, it's already activated, so I activate the fluid, the wax characterize fluid that has been tuned with saturation properties, or anyway PVT lab test data, any data that allows the CPA model to be tuned. So I activate this, and then I enter the WDT data at 50 degrees at 1 atmosphere. Then I press check. If you notice, it didn't give me any warning because the fluid has been tuned with saturation properties, and I let this to tune. Okay, now the tuning is done. You can see the correction factors, the Cutinho model parameters, and the objective function is very small. So I'm happy. That means that tuning was successful. And also you have a new fluid. If you're happy with the name, and I'm happy with the name, although it's a bit long, I'm happy with the name of the fluid, so I press save. And now this fluid is ready to perform any wax calculation. This fluid was ready to perform wax calculation as well, but it hasn't been tuned. The Cutinho model wasn't tuned for this one. Where is it? Okay, with this one, because it's only tuned with saturation properties. You could also perform wax calculation with this fluid, but it wasn't not the Cutinho model, not the CPA model wasn't tuned. They were not tuned, so the prediction wouldn't be reliable. But with this one, which has been both the two models, CPA models and Cutinho models were tuned, now you could perform any calculation and the predictions will be reliable.